you did it. So otherwise, it's not good for you. Okay, so I'll continue. Okay, so I'll be reading question first. It says we have a quadrilateral. It says square, which is CDEG. Okay, which doesn't look like, but it is. And then BE is 5. Okay, so we are told this guy is 5, and then CD is 3. So this is 3, which means this is also 3 because we are told this is a square. So let's label the angles. Okay, and this guy is also 90, but let me not label it for now. And the quadrilateral BEFH is a rectangle. Okay, so this is also 90, which is also 90 right here. Okay, interesting, because there's a 90 right here, there's a 90 right here, which might be helpful. And how many is BH? Okay, we are looking for this guy. I'm gonna call this as X, which is what I'm trying to do. Okay, so we do have, like, this is 3, BE is 5, and then if you do see this BD is just gonna be 4 because we have Pythagorean triple of 3, 4, 5, which makes this guy is 1, or you can just use the Pythagorean in this triangle to get that 1. Okay, and what we want is, like, all the numbers were given in this triangle, but this is what we want, which is not really related at first, but it's good to chase maybe some angles. Okay, this guy and this guy is parallel, and then this guy and this guy is also parallel because this was a square, so the opposite sides are parallel, and this was rectangle, so opposite sides are parallel, which is a good reminder of the hunting similar triangles, because you do have parallel lines, you do have right angles. Those are two biggest hint, I guess, that you need to look for similar triangles. So, for us to get some similar triangles, maybe we like to remember what are the ways to determine if two triangles are similar. So we have angle similarity, we have side angle side, and then we have side side. So we don't really have much information in terms of size, so which is why we cannot really use this guy. And then I don't really see two different triangles has some size information. We cannot really use this either. So only shot is basically angle. And I like to compare this triangle with something that I'm looking for, right? Because at the end, I like to use what I have and what I'm looking for. So if I label this angle, maybe alpha, and I can call this guy as beta. So in this triangle, like BDE, alpha and beta is add up to 90 degrees because this is 90, other two is add up to 90 as well. And that is something, this is 90, and I like to maybe compare like this guy with something, maybe that's also X, right? So if I find this guy, that is the same as HP. So since I don't really have any information about this triangle, I cannot really compare this triangle with this one that I have. But I do have something maybe going on right here because GE is the same as CD, which is a good reminder for us to maybe use this triangle and this larger one. But before we do, we need to show they are similar. So we know the angle GED, which is this corner, is 90 because this was a square, and alpha and beta is added up to 90. If this is alpha, then the other part should be same as beta. This is one way that we can say this guy has to be beta, or another way to say this is parallel to AD, which is why the angle would be this guy right here and this guy right here is equal because they are alternate interior angles. Okay, so yeah, two ways to get this is same as this guy. That's good. And what we can say more, this corner was 90 degrees as well. So this angle plus this angle has to be 90 as well, add up to, which is, we already know alpha and beta is 90 add up to. And then if this is beta, that means this guy will be alpha. And same goes the third one. So alpha and this angle at G is add up to 90 because this is 90. So which is why this guy has to be beta. So now we are actually almost there. So what we have basically two triangles, like, this guy has hypotenuse and one leg is what we are looking. Okay, and then this triangle is what we have, and we have all three sides. This is 3, this is 4, the hypotenuse is 5 because it's given. Okay, so that is 5. So we know the alpha, beta, and 90, alpha, beta, and 90, which means those two triangles are similar by angle. So if that's the case, we can actually write the ratio of the similarity, because when you have similar figures, they has to be proportional in terms of the size. So I will start with what I'm looking for, which is x. X is opposite to beta in the smaller triangle. So this triangle beta is opposite to 3. So just ignore this piece because we are talking about this triangle. So that's opposite to 3. In my smaller triangle that I start with, the hypotenuse is something I know, which is 3. The other triangle hypotenuse is 5. So that should be my corresponding side. And if you solve this equation, 5x will be 9. So the x will be 9 over what? 9 over 5. So the question was asking as a mixed number. So that will be 1 and 4/5. So I hope you were able to do this on your own as well. So if you didn't do that on your own, which is okay, that's why you are watching this, I hope. And that is one way to do so. But here's my challenge. Can you find the answer doing something different, maybe finding some other similar figures, and see if you can actually get this answer as well? And maybe you don't really need to use the similarity. So go ahead and try and see if you can find another way to do this problem. Okay, so I'll see you next time.